The Fowler TRIMOS Labconcept Nano is our most accurate gauge to date. This gauge offers 3-axis CNC motion control. In this video, we will outline some of the most common measuring applications. The Z and Y axes are actuated from within the measuring table. The X-axis carriage moves along the beam to apply an adjustable and consistent measuring force. For external diameters, a preload is first applied. The part is then swept in the Y direction to find the reversal point. Once this point is found, the load is released and then reapplied for the final measurement. Inside diameters larger than 1/2 of an inch may be measured with the L-shaped probe attachments. The process is nearly identical to that for the outside diameters. A preload is first applied. The part is then swept in the Y direction to find the reversal point. The load is taken off and then reapplied for the final measurement to be taken. Inside diameters too small for the L-shaped attachments can be accessed using a ruby ball probe attached to the internal measuring device. Here, a straight bore master ring is being measured by a ruby ball probe. You can see the left side reading being taken. The machine then reverses and sweeps for the center point on the opposite wall. Thread plugs could be measured with thread wires, shown here in dedicated holders. The associated gauge management software, QMsoft, maintains a database of the available wire diameters. It will select the proper wire diameter to use for a given thread pitch. Internal thread rings are a simple matter with the Labconcept Nano. For this application, the internal measuring device is outfitted with a T-shaped ruby ball probe. As with the thread wires, QMsoft holds a database of available probe ball diameters. Given the thread dimensions, the software will select the best available probe to measure the pitch diameter. This setup also shows the magnetic temperature compensation sensor. With the thread dimensions programmed and the correct probe selected, the operator simply positions the probe in the first thread to be measured. From there, the probe will sweep for a reversal point, then repeat the motion on the next thread down. To complete the measurement, this action is then performed on the opposing ring wall. This 3-point method can be used on straight or tapered thread rings. In addition to the pre-programmed measuring modes, the machine can also be manipulated manually through use of a mouse, touchscreen, or alternatively, with joystick. The Joystick control is as such: x-axis, left and right movement, the y-axis of the table, up and down, and the z-axis, twisting motion. There are also 6 pre-programmable buttons for certain functions such as external or internal measurement of a ring. All 3 degrees of freedom can be manipulated using these methods. And now for some of the features of the software. So up here in the top left corner is the main WinDHI control stream. This has your major numerical controls, so you're looking for minimum, maximum, all your presets, toggle between 9 different references, you can bring up or collapse the screen for the internal measuring device. This bottom left screen here is the controls for the automated table and the x-axis. So this right here is in the joystick control mode. Here you can put it in manual mode, set your speed, control the main x-axis or the z and the y at the table. Finally, we have pre-programmed measuring modes, where these are just solid measuring the x direction. We've got little graphics here to show internal groove, internal ridge, or straight internal diameter, as well as the opposite, external features, external diameter. These buttons over here are for taking step movements of a set dimension in any of these directions. For example, if you're switching between measuring planes on a ring or a pin, and you want to take a step of a known size, you would use the Z control, which right now is set for 1 millimeter. Bottom on the right, we have the step mode, which, when activated, will allow the user to manually pull the movable contact away from the pin and swap it out. And at the bottom are the Y and the Z controls with a little 0 button attached to each. On the right screen at the top is WinComp. This is our temperature compensation unit. Here you can see the readout for the temperature of the scale and the current temperature of the movable temperature probe, which will be attached to any piece being measured. This can also be used to graph temperature data over time, and can be set up to send alerts if the laboratory temperature goes outside of certain bounds. On the top right, we have QMsoft, which is a gauge management software. This left section here contains databases for any measuring tools or probes, such as our T-shaped ball probes or single ball probes, any masters we use in the calibration of those. The next section over are the inspection programs. For example, this is your plane gauge section, where you have the measurement tools for ring and plug gauges as well as snap gauges. Thread gauge section is very important because the automated thread measurement program is tied directly into the QMsoft. So as you're going through the process, you would enter in your thread dimensions, and these figures would later control how big of a step to take when the machine is actually measuring the thread.
First responders matter.